Today we're going to talk about an infinite geometric series. So last class we talked about finite geometric series. Finite, meaning there was a set number of terms. So as a reminder of what we talked about with finite, mostly we're talking about the sum. So because for any geometric series or geometric sequence, we still have our formula of a sub n equals a1 times r to the n minus 1. And that is to find any given term in a sequence. With a finite sum, we had this formula s sub n equals a1 times 1 minus r to the n divided by 1 minus r. And there's this really cool process we did to find out where that formula came from. A3, you did not get that part. But we will be covering something similar to it as we talk about infinite geometric series today. So the first thing that we're going to be talking about is whether a series is going to converge or diverge. So here's what both of those means. This is going to say the sequence approaches a finite value. Or another way to think about this, the limit as n goes to infinity is finite. So we'd be thinking about if a sequence is going to diverge, a sequence will diverge if it approaches infinity or no set value. So the limit as n approaches infinity of the sequence equals infinity, or the limit as n approaches infinity of a sub n does not exist. So when do these happen? Well, let's take a look. So I'm just going to list one out here. Let's do 2, 6, 18, is it 54? I'm trying to times by 3 every time. So I want you to notice that here, we have a sub 1 equals 2. And my common ratio here is 3 because I'm timesing by 3 every time. So as the sequence goes on and it gets bigger and bigger, like if I was to graph this, just like a quick little sketch, here's every value of n. It starts small and then it gets bigger and bigger, and it's just going to keep continuing this trend upwards, and it's just going to get huge, and it's going to look like it's like almost approaching a vertical asymptote, but point is it's essentially just doing this. So when I think about it in terms of limits, is that limit approaching a value or is it approaching infinity? In this situation, the limit is going to approach infinity, which means that this sequence will diverge because it's getting bigger and bigger every time. What if we did one that was like 2, 1, 1/2, 1/4, 1/8? So I still have my first term is 2, but this time my common ratio is 1/2 because I'm multiplying by 1/2 every time. If I was going to be looking at this, we could start 2, 1, 1/2, 1/4, 1/8. And you see how this one is just going to level out as it goes? So because on this one, the limit as n approaches infinity is going to equal 0. And because 0 is a finite value, this sequence is going to converge. So let's see if we can figure out like a rule for this. And I want you to look specifically at these values of our common ratio. And I want you to pause the video for a second and maybe talk with someone next to you. When do you think, based on our values of r, will a sequence converge or diverge? If you didn't pause the video, it's okay, I forgive you. A sequence will converge if the values get smaller every time. And that only happens when our common ratio is less than 1. So when we're multiplying by a fraction, aka dividing every time, that's when you'll see the sequence level off. Otherwise, it's just going to get bigger and bigger every time. So this is when the absolute value of r is bigger than 1. Let's do one more example just to make sure you got it. So this time I'm just going to write it like this. Well, here r is -2. And some people might think, oh, well, it's getting smaller and smaller every time. Well, with a negative number, like essentially if you were to graph this, like you'd start, let's see, 1, 2, 3, 4. Like A1 is 4. A2 is -8. A3 is +16. A4 is -32. So you see how this one is alternating? We call this alternating, and it's alternating because of this negative. So essentially, you'd be graphing going like this. Like just, well, that was a bad illustration. But it'd be like here, then there, then here, then there, then here, then down here. And so because it makes this kind of zigzag as you were to go through, you see how the limit in this one, this would be a does not exist situation. But that's a lot of extra work that we didn't have to do. Mostly I'm just looking for this, where since the absolute value of r is bigger than 1, this tells me that this is going to diverge. It's kind of nice because I like in this notation because r is just right there, and that's awesome. Okay, so that was the first thing that we needed to do. And there's only one more thing to do for this lesson, which is awesome.